In this section, we're going to discuss what we call the quadratic formula. And this is the third and final way, this is actually the fourth way, right? We know how to solve a quadratic equation by factoring, completing the square, extracting square root, and now we're going to get to what we call the quadratic formula, all right? The quadratic formula actually comes from completing the square on a generic quadratic equation, all right? But basically, the quadratic formula says the solutions to any quadratic equation in the form, and this is going to be important, it has to be in this form, ax squared plus bx plus c equals 0. So everything on one side set equal to 0. They're given by the formula x equals negative b plus or minus the square root of b squared minus 4ac, and everything, all right, everything is all over 2a, all right? Notice that plus or minus in there, and that means that we're going to actually get two solutions to this quadratic equation here, all right, if we have everything in its respective place. But a, b, and c are those coefficients in the quadratic equation, right? When everything is on one side set and equal to 0. So there's my a, b, and c. Once I know those coefficients, plug in my b, plug in my a, and plug in my c, and I'll have my formula, my solutions. Simplify and you have your solutions. Let's look at an example. All right, this first example says solve using the quadratic formula. I have x squared minus 6x plus 7, right? In this example, I have my a, b, and c in the right form, right? So whatever is in front of the x squared is a. So a is 1. B is going to be a negative 6. And c is going to be 7, all right? Now I'm going to write down my formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now I'm going to put my values in. All right, this is negative b, so I'm going to have a negative. Well, my b is negative 6, so that'll be a negative 6 plus or minus the square root of negative 6 squared minus 4 times a, which is 1, c, which is 7, all over 2 times a, which is 1, okay? And the rest is just simplifying, right? Negative 6 is a positive 6, plus or minus. All right, negative 6 squared is 36. If I subtract 28 from the 4 times 1 times 7, this is 28. I get 36 minus 28 as my radicand, and 2 times 1 is 2. All right, and the rest is pretty simple simplifying. Don't have to do much, but let's continue here. All right, that 36 minus 28 is going to be 8. So I have the square root of 8 over 2. And I'm sorry about that. I can simplify the square root of 8. All right, 8 is 4 times 2. So that'd be 6 plus or minus. Well, this is square root of 4 times 2. And if I take the square root of 4, I get 2. So that's 2 times the square root of 2 all over 2. And of course, since that is a fraction with one denominator, I can do my division separately. So that's 6 over 2 plus or minus 2 square root of 2 over 2, which will give me 3 plus or minus the square root of 2. 3 plus or minus the square root of 2. And of course, you can separate it. It would be 3 plus square root of 2 and 3 minus the square root of 2. Let's look at another example. We have x squared minus 7x equals negative 19. All right. Well, of course, this is not an ax squared plus bx plus c equals 0 form, so I've got to add 19 to both sides so I can figure out what a, b, and c are. So I get x squared minus 7x plus 19 equals 0, right? And my quadratic formula says x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, all right? In this example, a equals 1, b equals negative 7, and I made a mistake here, or my addition symbol kind of got mixed up. Since I was adding 19 to both sides, that means my c equals a positive 19. And so I'm going to put these values into my quadratic formula. I get a negative 7 plus or minus the square root negative 7 squared minus 4 times 1 times 19 all over 2 times 1 because a is 1. And the rest is just simplifying, right? So I get a positive 7 plus or minus the square root. Negative 7, quantity squared is 49, minus 4 times 1 times 19 is 76. Sorry about that. So I get 49 minus 76 under my radical, and 2 times 1 is 2. Of course, we need to figure out what 49 minus 76 is. That'll actually give you a negative 27. So I get 7 plus or minus the square root of negative 27 all over 2. And of course, we're going to want to simplify. Square root of negative 27 can be written as negative 9 times 3. And so if I simplify that, I'll get 7 plus or minus 3 square root of 3 times I all over 2. All right. And of course, if you want to, we can't simplify because 3 doesn't go into 7 evenly and doesn't go into this 3 on the outside evenly. But we can separate it, and you can write it as 7 halves plus or minus 3 square root of 3 over 2 times I. Okay. And those will be your two solutions. Okay, so that's the quadratic formula. It'll give you your two solution. It's just plugging in the numbers, doing the arithmetic to help you simplify. That is all that's involved with the quadratic formula. By the way, I know factoring doesn't work on every type of problem. Extracting square roots doesn't work on every type of problem. But completing the square does, and the quadratic formula does. And the reason why the quadratic formula does is because the quadratic formula is derived from completing the square. All right. So all problems you can use the quadratic formula. So this is one to remember. You have to remember that formula. It'll never be given to you. Always remember that quadratic formula. It'll be a lifesaver. Let's look at what we call the discriminant. All right, and that's that b squared minus 4ac portion of our quadratic formula, right? So I'm going to review, right? X equals negative b plus or minus the square root of b squared minus 4ac all over 2a, right? And so this discriminant is this b squared minus 4ac. The discriminant tells us some great things about our solutions, all right? It'll tell us the number of solutions we're going to have and the types of solutions we're going to have, all right? Let's look. I want to look at when my discriminant is a positive number, is equal to 0, and I want to look at when it is negative. All right, those are my three cases. All right. Now, in the previous example, all right, 2 examples ago, we looked at an example x squared minus 6x plus 7, and in this case, our discriminant became 8, right? 8 is positive. At the end, I noticed that I had 2 solutions because I have this plus or minus here. And they're both real numbers. I don't see an imaginary number, all right? So when I fill in my chart, when my discriminant is positive, I'm going to have 2 real solutions. 2 real solutions. Now I'm going to go to when my discriminant is negative. In part B, we had x squared minus 7x equals negative 19. When we did our discriminant and simplified it, we got negative 27, right? That's negative. All right, negative 27. When we got our solution, we had 2 solutions. We have this plus or minus here, and it had an I in it. That means we had 2 complex, right? 2 complex. And actually, I'm going to say 2 non-real solutions. because a real number is a complex number. It just doesn't have an I part. All right. And so you might want to say complex. It has the imaginary point. Okay. Now what we want to do is we want to talk about when we have 0 as our discriminant. All right. Well, if our discriminant is 0, this will be the square root of 0, and the square root of 0 is just 0. So our thing will be negative b, our formula will become negative b plus or minus 0 over 2. Well, when I add 0, I'm still going to have negative b. When I subtract 0 from b, I'm still going to have negative b. So this is still going to be a negative b over 2, which is just one single solution. All right, and that's real. It's actually a rational number, but we're just going to say one real solution. Sometimes that is important when we're trying to solve a problem, because sometimes we don't want imaginary solutions, and if we look at the quadratic and it gives us imaginary solutions, meaning the discriminant is negative, then we need to figure out another polynomial that'll work for us. There is one other thing that we get from our discriminant, all right? And it says that if the discriminant is a perfect square, then the quadratic, I'm going to abbreviate it with quad, can be factored. All right, and so when I'm trying to factor something that is kind of outrageous and I want to know if it can be factored, what I do as your teacher is I just go ahead and do the discriminant, and if it's if it is a perfect square, then I know it can be factored. If it's not a perfect square, then it cannot be factored, and your quadratic is considered prime. All right? Let's look at some examples where we actually figure out the number and types of solutions for a quadratic. All right? Part A, we have x squared minus 9x plus 16 equals 0. All right? Well, if I want to just find the number and types of solutions without actually doing the whole problem, then all I'm going to do is look at b squared minus 4ac. Okay, well, b is 9, negative 9. A is 1, c is 16, right? And so negative 9 squared is 81. Minus 4 times 1 times 16, that'll give you negative 64. And if you subtract 64 from 81, right, so let's put some equal signs here, you're going to equal a positive 17. Okay, so my discriminant here is positive. And when my discriminant is positive, that means I'm going to have two real solutions. Okay, now I know this problem didn't ask us, but now that I know that my discriminant is 17, if I were to ask you, is this polynomial, is this quadratic equation factorable, I would hope that you would say no, it's not factorable, because 17 is not a perfect square. Okay, but I get two real solutions. This is my answer here. All right, let's look at part B. I got 4x squared minus 12x plus 9 equals 0. All right, again, we're going to do b squared minus 4ac. Okay, b is negative 12 minus 4 times a, which is 4, times c, which is 9. All right, and negative 12 squared is 144. And 4 times 4 is 16. If I multiply 16 and 9, I get 144. And so what we have here is a discriminant of 0. Okay? When my discriminant is equal to 0, I'm going to have one real solution. Now, if I were to ask you, is this going to be factorable? I would say yes, it is factorable, right? Because 0 is a perfect square, right? 0 squared is 0. And so there we have our solutions, number of solutions, one real solution. All right, the last thing I want to talk about in this section is an important application of quadratic equations. So now that you know how to solve quadratic equations using all four methods, now we're able to do a bunch of application problems. One of the application problems we're going to discuss is projectile motion problems. All right, a projectile is an object upon which the only force acting on it is the acceleration due to gravity. All right. For instance, I'm going to draw. Let's say someone is standing. Let's say we have a hill or a mountain, and this person is standing up here on top of the mountain with a ball in their hand. And they're going to throw the ball, and the ball is going to go up, and then it's going to go down. All right. This is what I call a projectile. It's going to go up, and then it's going to go back down. All right. So the ball is going to be here at a certain time. It's going to be here at a certain time, here at a certain time, here at a certain time, and here at a certain time. All right. Well, we can kind of quantify or see what path this ball is going to be flowing from or traveling on by creating an XY plane. All right. So I'm going to create an XY plane. All right. And my ground level. So this is my x-axis. Let's say this is my y-axis. Now, if I want to know the position of that ball at a certain time, then instead of using x and y, I'm going to let my x-axis represent now my time, or my time in seconds, how far the ball or how long the ball is from the start to finish, how far it's been traveling from start to finish based on the time. Time is in seconds. That's what I'm trying to say basically. And this y-axis is going to actually represent my height of the ball. And I'm going to measure that in feet. Okay. Well, since it's a projectile, the only thing that is acting on it is acceleration due to gravity. And so at a certain time, for instance, let's say that this is 1 second, right? Let's say that this is 2 seconds, this is 3 seconds, this is 4 seconds, and this is 5 seconds. Then if I want to find out how fast the ball, where the ball is, how high the ball is at 1 second, then all I have to do is on my x-axis, go to the right one and up, and I'll get my y coordinate, right? So whatever that y value is. This general shape that this ball or this projectile is traveling is called an upside down parabola, all right? And the graph or the equation of a parabola is actually a quadratic equation, all right? So that's the relationship here. Now, quadratic equations extend, they're going to continue to extend indefinitely. And we're going to talk about the graphs of quadratic equations. But in real life, we don't worry about this space over here. This is considered negative time. And these heights down here are negative heights. We're only worried about this actual space that the actual object is flying. And it's going to be modeled by a quadratic equation. The actual quadratic equation that models this, and I do want to make sure you're aware that we're not considering any wind speed or any resistance besides it just being in the air and just going back down. But the quadratic equation that models any projectile, all right, the height of any projectile, is this quadratic equation here. H of t equals negative 16t squared plus v naught t plus s. Now, I want you to know, don't want you to get a little too confused here, right? T is like your x values. H of t is almost like saying f of x. So what we said before was f of x equals, we say negative 16x squared plus v naught times x plus s. All right. Now, we normally see this. There's a number sitting in here for v naught and s. All right. V naught is the initial velocity. I will always give you that. I'll tell you how fast the person is throwing the ball initially from the time they're throwing it off the hill. All right. The initial height is how high the ball is at the time equals 0, the initial time. All right. I'll always tell you this as well. T is the time, and h of t is the height in feet. So T is for time, h is for height. And so what we're going to do is we're going to use this knowledge of this situation and we're going to solve some problems. Let's look at an example. In this example, a rock is thrown upward from ground level at an initial velocity of 80 feet per second. What quadratic function represents the situation given in the problem? All right. Well, I'm going to draw a picture to kind of help me out, right? So I'm on the ground. This is ground level here. I'm throwing the rock here. This is where I'm starting on ground level. And it's going with the initial velocity of 80 feet per second. Well, that doesn't help me in my picture, but I know I'm going to throw my rock up, and then it's going to come back down, all right? And so what I want to know is what quadratic function represents the situation that's given in the problem. Well, hopefully we've memorized the general formula for a projectile motion problem. And it's this formula here, okay? Our goal is to figure out what V0 is, the initial velocity, and what S is, our initial height. Well, they give us the initial velocity in the problem. It says the initial velocity of 80 feet per second. All right, so V0 is going to be replaced by 80. Now I need to think about the initial height. So they didn't give me this explicitly. But if you look at this, it says a rock is thrown upward from ground level. Well, the height on ground level or from ground level is 0 feet, right? Ground level is ground level. That's where we start. So our S is going to be 0. And so the quadratic function, I'm just going to put 80 in for V0 and 0 in for S. I get h of t equals negative 16t squared plus 80t plus 0. Of course, we don't have to write the plus 0. So this is my quadratic equation, or quadratic function that is represented here. Okay? Now I'm going to go to part B. It says, after how many seconds will the rock land on the ground? Well, the rock starts on the ground here, and I want to know at what time will my rock be here, right? So I want to solve for t, right? How many seconds? That means I'm solving for t. When the rock lands on the ground. Well, the ground is at ground level, and that means the height is 0. All right, so I'm going to solve for t when h equals 0, the height equals 0. Well, this is my height right here. And so I'm going to put 0 in for my height. I get 0 equals. And I want to solve for t. So I'm going to leave t alone and try to isolate it. Well, of course, this is a quadratic equation. And with quadratic equations, we have 4 ways to solve it. Factoring, extracting square roots, completing the square, quadratic formula. This example is probably easiest done by factoring. All right. Greatest common factor is 16. Since this is a leading coefficient, is negative. I'm going to factor out a negative 16. Both of these have at least a t in them. So 16t is my greatest common factor. When I factor that out, I'm going to be left with a t minus 5. Now I have two things that if we multiply it together, we get 0. Right? These are my two things. So I'm going to set them both equal to 0. Negative 16t equals 0. And t minus 5 equals 0. All right. Here I can divide by negative 16. I get t equals 0. Here I can add 5 to both sides. I get t equals 5. Notice I have two solutions here. And of course, I'm definitely going to have two solutions, right? Since it initially started on ground level, this is my t equals 0. And it's going to go up, come back down, and this is going to be t equals 5. So it takes 5 seconds to answer my problem, 5 seconds for the rock to land on the ground again. Okay, let's look at one more example of this projectile motion type problem. A projectile is launched upward at an initial velocity of 100 feet per second from a platform that is 60 feet high. Round to the nearest hundredth of a second. All right. I'm going to draw the situation that's going on here. All right. Got my projectile. And instead of starting on ground level, we're starting 60 feet above ground, right? So this distance here is going to be 60 feet. So the ball is going to be thrown up, and then it's going to go back down, all right? And so I wanted to figure out what quadratic equation or function models this situation here. I've memorized this, sort of. All right, my goal is to figure out what V naught equals and figure out what S equals. This time it's a little simpler. V naught, the initial velocity, is 100 feet per second. Initial height, 60 feet high. And so I'm explicitly given that. So my V naught is 100, S is 60. And so my quadratic function that models this situation, h of t is negative 16t squared plus 100t plus 60. This is my quadratic function. In part B, we want to know when will the projectile be 125 feet above ground. All right, when will the projectile be 125 feet above ground? When they ask us when, they're meaning find or solve for t, find t. If the projectile is 125 feet above ground, that means the height, or h of t, is 125. Okay? And so what I'm going to do is, now that I have my quadratic function here, I'm going to substitute 125 in for h of t, so I get 125 equals, and then everything else is going to stay the same because I need to solve for t. So negative 16t squared plus 100t plus 60. All right. Now this is a quadratic. I have those 4 ways to solve it. I'm going to solve by using the quadratic formula because these are some big numbers and I don't want to solve by factoring. So I'm going to subtract 125 to get everything on one side set equal to 0. And when I subtract 125, I get the equation 0 equals negative 16t squared plus 100t minus 65. All right. And now I have that. I'm going to use my quadratic formula. With my quadratic formula, we have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That'll be a negative 100. Right, because a equals negative 16, b equals 100, and c equals negative 65. Okay. So negative 100 plus or minus the square root of 100 squared minus 4 times a, which is negative 16, times c, which is negative 65, all over 2 times negative 32. Okay, so we get negative 100 plus or minus, the rest is just simplifying. 100 squared is the same thing as 10,000. And if I take 4 times negative 16 times negative 65, and if I put that negative with the 4, I'm going to end up with a negative 4160. Okay, that's the same thing as 64 times 65. Okay, all over, well, since my a, and I made a mistake, this should be a 2 times a negative 16, which is going to end up giving us that negative 32. Thinking a little bit ahead. Okay. Well, if I take that 10,000 and subtract that 4160 from it, I'm going to be left with 5,840. And so we get negative 100 plus or minus the square root of 5,840 all over negative 32. Our directions in this problem asked us to round to the nearest hundredth of a second. That means 2 decimal places. And so what I'm going to do is I'm going to go ahead and write my solution separately. So I'm going to have the plus, and I'm going to have a solution with the minus. And then I'm going to put these two in my calculator, and that will help me round to 2 decimal places. My result that I get when I plug in my first solution is 0.74 seconds. I round it to 2 decimal places. And when I plug it into my second solution, I get 5.51 seconds. All right, and so I have 2 solutions here. Neither one of them is 0, but if I go back to my problem, 125 feet is, I hit that 2 times for my problem, so 125 feet may be right here and right here. All right, there is a possibility that you will get 2 solutions and both of them are valid. All right, so I'm going to say that both of those answers are valid, and so I have my solution here. All right. So I get 0.74 seconds and 5.51 seconds. All right, this concludes our video of the quadratic formula.